Okay, in this video, we're going to take a look at the conditional statement, at the conditional relationship, and we're going to discuss a particular kind of inference that you can make from any conditional statement. Alright, so taking a look at our statement, we have here, if Hilda is in law school, then Hilda took the LSAT. And we have our standard diagram, law school, and then arrow to the right, and then LSAT. And now the question is, what can we know from this? So we already know that this is just a hypothetical. We know that Hilda is not in law school. We don't know whether or not Hilda is in law school and whether or not Hilda took the LSAT. We just know what would happen if she is in law school. But is there anything that we can know from this? Well, we know that taking the LSAT is a requirement for going to law school. That's simply what a necessary condition means. We know that's our necessary condition up there. And if you don't meet a requirement for something, then you don't get that thing. That's you can't have the first without the second. That's what that means. That if you don't have the second, taking the LSAT, then you don't have the first. You're not in law school. So since the LSAT is a requirement, that means that if Hilda didn't take the LSAT, then she's not in law school. But if you noticed, that's also a conditional statement. If Hilda didn't take the LSAT, then she's not in law school. And here we'll put up here next to our original conditional statement, and we have, if Hilda didn't take the LSAT, then Hilda isn't in law school. So what that means is that the first conditional tells us that if Hilda is in law school, then Hilda took the LSAT. And once we're told that, we can immediately infer the second conditional, that if Hilda didn't take the LSAT, then Hilda isn't in law school. And the reason we can do that is because the necessary condition is a requirement, and if a requirement isn't met, then the first thing doesn't happen. So basically, whenever we're given any conditional relationship, we can automatically infer another conditional relationship based from that first one. Okay, so how do we diagram this? Well, it's very simple. You just take the necessary condition, you make it sufficient, and you negate it, and then you take the sufficient condition, you make it necessary, and you negate it. So you just take the conditions from the first conditional, you switch them around, and you negate them, and you'll get what we have here underneath our second conditional statement, is we have an LSAT with a line through it, which is just the standard way of diagramming negation, followed by the arrow line, followed by law school with an arrow through it. And as you see, it's the exact reverse of what we have in the conditional and the conditional diagram on the left. And this is called the contrapositive. And this is very important. This is going to be very important on the test, and it's going to be very useful on the test. So keep in mind that whenever you have a conditional statement, you can always infer its contrapositive. Simply switch around the conditions and negate them. So for example, if we take a look at this conditional statement, if the switch is flipped and the lights turn on, our standard diagram of that is light switch, then arrow, then light. And as we mentioned, every conditional statement has a contrapositive. The contrapositive doesn't depend on the content of the statement, and you simply use the same procedure of switching and negating. So here we have the contrapositive of this statement is if the lights don't turn on, then the switch isn't flipped. And we have light with a line through it, followed by an arrow, followed by light switch with a line through it. So it's simply if you know you have a conditional statement, you know you can always find a contrapositive. And so once again, according to this conditional, you can't flip the switch without having the lights turn on. Therefore, if the lights don't turn on, that means that the switch isn't flipped. Same thing with this conditional. If you love me, then you'll take a shower. Love me, arrow, shower. The conditional is if you don't take a shower, then you don't love me. Shower with a line through it, arrow, then love me with a line through it. A requirement for loving me is taking a shower. So if you don't take a shower, that means that you then don't love me. Okay, so to recap, the contrapositive is a valid inference from the conditional statement where the sufficient condition is negated and becomes the necessary condition, and the necessary condition is negated and becomes the sufficient condition. And to diagram it, simply switch and negate the conditions.